Hello students, last time we were doing parabola. Right now the one more section of conic is ellipse. So we are going to start ellipse. So if we are talking about the definition, it is a set of points in a plane, the sum of whose distances from two fixed points in the plane is constant. Suppose we have 2 points on this line, point F1 and point F2. Now the ellipse is a set of all these points, which are the sum of these points from these 2 points. Suppose we are taking a point P1 and point P2. Now if we join point P1 with F1 and we join point P1 with F2, similarly if we join F1 with P2 and F2 with P2, then here we can say that F1 P1 plus P1 F2, which is exactly equal to F1 P2 plus P2 F2, or we can say it is greater than F1 F2. Here two fixed points are foci of ellipse. We can say F1 and F2 are foci of ellipse. Here this point is point O, and we can say O is the center of ellipse. AB, if this point is A and this point is point B, so we can say AB is major axis of ellipse, and CD, suppose this point is point D and this point is point C, so we can say CD is minor axis of the ellipse. Here AO, which is equal to OB, which is equal to A, and OC, which is equal to OD, which is equal to B. We can say AO and OC are, AO is semi-major axis and OC is semi-minor axis. So here we can say F1 F2 is equal to 2C because of OF1, which is equal to OF2, which is equal to C, and A and B are the vertex. We can say A and B are the vertex of the ellipse. So here again we can make a new graph. This point is point A, point B, it is point C, this is point D, this is point O, and these 2 points are focis F1 and F2. So if we connect this point with F1 and F2, we know that the distance of OF1 is equal to C and OF2 is also equal to C. Now F1C, which is equal to under root B square plus C square, because of CF1O is a right triangle, so here F1C is equal to sum of square of OC and OF1. So here F1C is equal to under root B square plus C square. Similarly we can find F2C, which is equal to B square plus C square. It is also B square plus C square. Now F1C plus F2C, which is equal to 2 under root B square plus C square. OA is equal to A, so it shows AF1 which is equal to a minus c. So according to the definition of ellipse, we can say AF1 plus AF2, which is exactly equal to 2 under root b square plus c square. Further, a minus c plus a plus c, which is equal to 2 under root b square plus c square. Further, a is equal to under root b square plus c square. So we can say from here c is equal to under root a square minus b square. So we know that we can find the value of c, which is under root a square minus b square. Now here, when we can see that when c is equal to 0, it shows that a square, which is equal to b square, or we can say a is equal to b. So ellipse become, in this case, ellipse become circle. And when c is equal to a, it shows b is equal to 0, then we can say ellipse becomes line segment. Ellipse becomes line segment. So in these two cases, ellipse can change in circle or line segment. Now we are talking about one more point in the ellipse, which is eccentricity. So first of all, what is eccentricity? Ratio of the distance from the center of the ellipse to one of the foci and to one of the vertex of the ellipse. So here E is equal to, we can say, C by A, because of ratio of the distance from the center of the ellipse to one of the foci and to one of the vertex of the ellipse. So here we can say C is equal to EA. So now equations of the ellipse. Here this is point A, point A, point B, point C, point D. This is point O, F1, F2. Suppose this is point P. So here connect point P to F1 and F2. Now here let F1, F2 are foci. O is the center. So coordinates of F1 we can say minus C, 0, minus C, 0, and coordinates of F2 are C, 0. We know that PF1 with plus PF2, which is equal to 2A. From here PF1, which is equal to x plus c whole square according to the distance formula, plus y square plus under root x minus c whole square plus y square, which is equal to 2A. Now further we can write it as x plus c whole square plus y square, which is equal to 2A minus under root x minus c square plus y square. Now square both sides. So x plus c square plus y square, which is equal to 4a square plus x minus c square plus y square minus 4a under root x minus c whole square plus y square. Now after solving this we get 4xc, which is equal to 4a square minus 4a under root x minus c square plus y square. Here xc is equal to a square minus a under root x minus c square plus y square. Now after that x minus c square plus y square, which is equal to a minus c by ax. Again we can square both sides. X minus c square plus y square, which is equal to a square plus c square upon a square x square minus 2cx. Now after solving this we get x square minus 2cx plus c square plus y square, which is exactly equal to a square plus c square upon a square x square minus 2cx, x square plus y square plus c square, which is equal to a square plus c square upon a square x square. Now further we can write it as x square plus y square plus a square minus b square, which is equal to a square plus a square minus b square upon a square x square. Now after solving this equation we get x square upon a square plus y square upon b square, which is equal to 1, and it is the equation of ellipse. Similarly we can find one more equations. We can say similarly if we have the position of ellipse like this, in this condition it is y-axis, in it is x-axis. In this condition this point is point O, so F2 is here and F1 is here. Now the coordinate of this point is minus b comma 0, coordinate of this point is b comma 0, coordinates of this point is 0 comma a, and here 0 comma minus a. Now the equation of this is equal to x square upon b square plus y square upon a square, which is equal to 1. In this case the equation of ellipse is this. So here we can say the standard equation of ellipse have center at origin and the major and minor axes are coordinate axes. So here ellipse is symmetric with respect to both axes. The foci always lie on major axis. Now the one more thing in ellipse is latus rectum. Now what is the latus rectum? Line segment perpendicular to major axis through any of the foci. So here if we make a diagram, so here suppose F1 and it is F2, so the latus rectum is line segment perpendicular to major axis through any of the foci. So major axis is x-axis, so here we can say line segment through foci. These two line segments are here AB and CD. So we can say AB and CD are two line segments which are latus rectum for the ellipse. So let AF2 is equal to L. Then we can say coordinates of A is C comma L, and coordinates of A become C is equal to, we know that A E comma L. So here point A lie on the ellipse, so we can say x square upon a square plus y square upon b square, which is equal to 1. So here we can put this point on the ellipse, so ae square upon a square plus a square upon b square, which is equal to 1. Further it reduced in a square, which is equal to b square 1 minus e square. So now we know that e square, which is equal to c square upon a square, further which is equal to a square minus b square, because c is equal to under root a square minus b square. So here we can put the value of c square upon a square, which is equal to 1 minus b square upon a square. So here we can say L square is equal to b to the power 4 upon a square, and further we can write it is L is equal to b square upon a. So now the length of ratus rectum, here the length of ratus rectum is 2L, so we can say it will become 2b square upon a. So it is the length of ratus rectum.